Hey everybody, this is section 3.2, constructing a perpendicular bisector. First we're going to define a couple terms here. A segment bisector is a line, ray, or segment that passes through the midpoint of a segment. A bisector that is perpendicular to a segment is called a perpendicular bisector. Note that a segment has many perpendiculars and many bisectors, but in a plane, each segment has only one perpendicular bisector. In the three diagrams below, we show this statement. On the far left, segment AB has many perpendiculars. In the middle diagram, segment AB has many bisectors, each passing through the midpoint O. And finally, the diagram on the right shows that segment AB has only one perpendicular bisector. The perpendicular bisector conjecture. If a point is on the perpendicular bisector of a segment, then it is blank from the endpoints. Take point B, for example, in our diagram above. What is the relationship between the distance of B to point P and the distance from B to point Q? Well, being that it is on the perpendicular bisector, we know that point B is equidistant. To both points P and Q, which are the endpoints of the segment. Now let's talk about how to construct a perpendicular bisector of a segment. So we're going to talk through this. We have a given segment here. Let me shorten it just a little bit so I have enough space. I have my compass. So to construct a perpendicular bisector, I'm going to take my compass and place the point on one of the endpoints. Then I have to extend my pen. Then I have to extend my pen more than half the distance of that segment. Next, I'm going to strike an arc above and below the given segment. Then, keeping my compass that same distance, I'm going to bring my compass over to the other endpoint and do the exact same thing. And what I'm looking for is the intersection of the two arcs above the segment and the two arcs below the segment. Now, taking my straight edge, I can connect the intersecting segments, or excuse me, the intersecting arcs above and below, and that becomes the perpendicular bisector of the segment. So if I wanted to name, I could call this point A, point B, and now I could also name, I'll call this C and D. And now CD is the perpendicular bisector of segment AB. You may want to rewind and re-watch the construction of this perpendicular bisector. The converse of the perpendicular bisector conjecture. So a converse is a statement that we switch the beginning and the end of the statement. So what we're doing is we're taking the perpendicular bisector conjecture that we stated previously in the video, and we're switching the beginning and the ends of it to come up with the converse. This conjecture states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. And a few more definitions. First, the median. The median is a segment connecting a vertex to the midpoint of the opposite side of a triangle. In the diagram, you can see that we are connecting a vertex right here to the midpoint of the opposite side, and the resulting segment is called the median. Each triangle will have 3 medians. Now let's define midsegment. A segment that connects the midpoints of 2 sides of a triangle. You can see in the diagram that we have the midpoint of that side and the midpoint of that side, and the segment connecting those is called the midsegment. Again, every triangle will have 3 midsegments. While in this video we are just defining these terms, we will eventually construct both medians and midsegments.